Welcome to this talk on the state of typesetting in the front end. My name is Jason Harris. I'm a senior developer with Wolfram Research, and I'm sort of responsible for the underlying structures of the front end. That is the box representation of structures in the front end, the things you evaluate and typeset and work with. And so this talk / presentation / workshop / tutorial will be a bit of a recap of some of the stuff that we've had before. There is some new stuff in here, but it's a very, very important subject in Mathematica, and any Mathematica developer actually really needs to know about the actual fundamental underlying structures of Mathematica and how typesetting works. And so it's a very important topic. And so in this topic, I'll be talking about boxes and many other things leading up to template boxes. And template boxes are now the standard way we do a lot of the typesetting and extensions to notations and structures in Mathematica. And then further on from that, we'll be talking about dynamic template boxes, which are again a way to unify the dynamic paradigm with template boxes themselves. Okay, so to get there, I'm going to be zipping through some stuff on boxes, style sheets, make boxes, and make expressions, so we can get up to talking about association template boxes, dynamic template boxes, and display functions. Right. With that preamble, let's get going. Okay, so way back when we had in the start of Mathematica with two-dimensional typeset notations, we could enter things like this, and then they sort of work. But it quickly became apparent that we'd come up with things like this, and we want to extend Mathematica the notations, and we need to be a way to actually sort of add this to the whole system. You need to, and we actually need to do this internally. Okay. So that's the goal, to be able to extend it on structures and work with them and be able to compute with these new sort of structures and extend Mathematica, or you extend it. Okay, so to be able to extend it, we have to know how everything works. And everything actually underneath is actually a box. And so we can actually go and take a look at the underlying structure of a box or a cell by taking a look at show expression. And here we see this x cubed. That's actually a superscript box right here of x cubed. And the whole thing is, there's a plus, there's a 4, and it's all grouped by a row box. And in fact, we could go in and change the boxes here, and it works as you'd normally expect, or you change it normally through the Mathematica editor itself. And it's the same results. And now we can go to a more complicated example. Here we see this integral. We can take a look at that using Command-Shift-E again, and we see there's a sub-superscript box for the integral part with infinity. There's an exponential e. It's all grouped by a superscript box, and so on. And we could go and we could change that as we did before, and it all evaluates and works as it should. Okay. So to be able to actually take a look at the underlying boxes and sneak a peek at them, we can actually use this trick of using an input field with the boxes and actually having the boxes as an output form of that. And now as we type into this box, we can actually see that the plus is a flat structure. This is what it's being represented as internally in the front end. And of course, if I change that box structure here to have a times, we see that there's a different grouping because of course the precedence of times is higher than the precedence of the plus. And so as we type expressions, a little bit more complicated expressions into Mathematica here, we see the actual underlying representation. That was a sub-superscript box. There's an exponential e, and so on. Another superscript box, and the differential d and an x. And so as we type the structure, we see the underlying boxes change and morph and transform and delete and modify themselves in response to what we've actually typed. And so the fundamental underlying system of the front end is actually not a text editor. It's actually a box editor, a box parser. And that's what I work in along with my colleagues. And so given that, you might say, well, that's only good for sort of math, but it turns out that actually all of the graphics itself, like graphics box, it's a line box. It's true for graphics that are boxes. In fact, a Bezier curve, for instance, is a Bezier curve box, and there's point boxes, and all the 3D boxes, 3D graphics, and everything else. They're all boxes as well. Styles, that happens to be a style box. A button, as we look at it, click on it, it's actually a button box. A slider and a dynamic here, and this is this dance between the front end as the front end is changing this value of mn. It's sending this off to the kernel. The kernel's responding with a new output for this dynamic, and we get this dance back and forth between the slider and these dynamics. And of course, slider is itself represented by a slider box, and a dynamic is in fact a dynamic box. And if we take a look at something, AI is the new hotness, of course, we'll go and take a look at some particular, like a net graph, and go Command-Shift-E on that, and we'll see it's of course a tag box, a template box, all this kind of stuff. So everything is boxes, everything. And so it's all about boxes. So to actually work with boxes, we need to know how boxes are sort of evaluated. What's this evaluation model in Mathematica of boxes? And so here, if we take a partial derivative of sine y over 2, we get, of course, the derivative of sine is cosine, and that shouldn't come as a surprise to anyone. And so how is that working? Well, Mathematica has this nice two-dimensional typeset form of the sine y over 2, and that's represented internally by boxes. And so we see it's represented by boxes. Those boxes will get sent off to the kernel and get parsed by make expression. Those boxes are made into expression, and here we get this sort of linear form of the as you normally type into a terminal in ASCII of the expression, and of course that gets evaluated in the kernel to a new expression, the derivative of sine is cosine, and that'll now get formatted into via make boxes, a new box structure, and that box structure gets passed to the front end, and the front end displays that in a nice 2D typeset way, and that's how we perceive evaluation to happen. So every time when we actually get some sort of input like this and hit shift return, it's actually going through a make expression, evaluation, and then a make boxes to get back to the front end. And it's interesting to see this in Link Snooper if you want to. So given that that's how things work, how do we actually extend things? So we turn around, and so let's go back to our example here of plus here, and this doesn't work. We see it's got an error in it. The syntax Mathematica doesn't understand this, and that's because, of course, there's no formatting rules. It doesn't know how to parse. There's no parsing rules, sorry, I should say, for that to actually work. And so then we can actually try and see that ourselves, and so we could try and see that make expression on this particular box structure here, right here. Standard form here is actually giving us an error box, and so there's no definition for it. So what we want to do is define this in terms of some other boxes that it does know how to make. And what are some other boxes that it does know how to make? Well, that's PD plus, for instance, of V. And so we can actually go take and get those boxes and turn around and plug those in. And so now we've told Mathematica that it can make this expression, make an expression from those boxes via this. And of course, that sort of works, but it's not general because, of course, this isn't general. And so we want to change this to a general pattern V and put this in. And now we've got something that parses, and it works as we'd expect here, gives us sort of the right things and has, the correct full form as would work with it. Okay, so to make this a full notation, of course, we want to be able to, so we've implemented this side, the parsing of this notation. We need to implement the formatting of this. And so we'd like a PD plus of V to actually format in this nice partial plus sort of thing. And so what we do is, of course, we make a make boxes rule. We're going to make this in standard form here into some boxes. Well, which boxes? These boxes. And so something else like that. So that seems to sort of work. That sort of works, but we get this weird cell context thing. And especially if we put this in, it gives us, there we go. It gives us some weirdo sort of box, and that's because the actual box structure is here as we've got it. It's a row box, a subscript box, blah, blah, blah. But this is an expression, and it should be boxes. So make boxes is taking an expression and giving us boxes, and that's all boxes except for that. That's still an expression. So we need to formally make this a bit more on this side and make that into boxes here. And now, of course, when we make this, it'll actually format as we want. And so this is now a full notation. And of course, we can then turn around and actually write rules in this. The partial plus of the sum is equal to the sum of the partials. And of course, we haven't done anything more than just give it and specified it in this nice new notation that we've got. And now we can evaluate stuff with this new notation. It's not quite correct. It's because this actually should be a parenthesis, but I'll talk about that later. So here, when we actually want to enter it, one of the tricks is we could enter all these boxes in. That sometimes is a bit hard. So a much easier way is actually enter it in sort of a linear form and then go to cell convert to standard form right here. And this will now turn it around into something that actually makes sense if this is syntactically valid. And so, of course, it has a right full form, and that goes back to an input form, that goes back to the traditional form and a standard form. Okay, and I'm going to skip over evaluation and make boxes and make expression. It's a very complicated subtopic, and it's something you should be aware of. And so when we're doing stuff, we don't want things like print of 1 plus 1 here when we're actually changing to standard form or traditional form or so on to ever evaluate. And so you've got to take extra care. Okay, so let's go zipping through some examples quite quickly. Here is one of the function. It's a standard form of function that's built into Mathematica. It works. But what happens if we wanted all of our functions to actually sort of look like that? Well, we can actually now, since this is the internal form, we're having a make boxes. It's taking make boxes is taking an expression and giving us a new form of boxes. And as we saw from before, we further make boxes on the V and then make boxes on the F. And now as we define it, we've got all of our various functions are actually displaying in this sort of nice form that is a bit more recognizable for mathematicians. Okay, another example is up and down. Here is, maybe for spin glass in physics or something. And so if we define these particular rules in much the same way as we did before, we can now make this, work and parse, and it works and parses and formats as we would expect. Okay. So this allows us to now, with that background, that's again a zip through really quickly to get to the stage. We can actually now start talking about template boxes. And so, what are template boxes? So here is I'm tabbing through the elements of the template box. I can change a particular parameter, evaluate it, and as you can see, I can't select the bracket. I can only select the individual elements and tab through them. So it's sort of a templated structure. And of course, since we've just talked about boxes, it would say, well, what would this box be? It would actually be a grid boxy thing with some brackets like that. That's what we'd expect to see when we Command-Shift-E on this particular structure. And so let's do that, and we see it's not that at all. It's two parameters, M and K, and just the string tag binomial. That's enough to allow it to display and evaluate the right way. And in fact, we could turn around and now change this to Bessel J, and now it looks like a Bessel J function. We can change some parameters, and it works. And so this, just by a Bessel J, has the right display and evaluation semantics. And in fact, we could turn around and go Legendre P, Legendre P, damn it, Legendre P, damn it, Legendre P, if I can get that spelled right, there we go, the Legendre P function, and it'll work like a Legendre P. And so, X there and Y and so on. Okay, so, and this is, we've got the parameters here, but it's just by the name that it can actually figure out what the correct evaluation semantics and the correct display. How is this magic working? Well, TemplateBox has options, and one of those options is the display function, and a display function is a box function. And what's a box function? A box function is some pure function that takes box arguments and spits out a box. And so this box function acting on the parameters will give us an actual box, and if we display that box, it will look like so. And in fact, if we evaluate now this template box, we look at it, it looks exactly the same. So what the template box is doing is it's taking its display function and it's applying that to its arguments, and that's how it's actually displaying the output. And moreover, when we actually enter in some sort of parameters, it's actually feeding that parameter back into the argument list of the template box, into the parameter list of the template box. And now it has also the right tooltip. It has, because it's done. Tooltip is automatic. It uses the string name here, and it has the evaluation semantics of using the string name because the interpretation function is automatic. And so, we could go in here and we could change that to, that P to a Q, for instance, and, it would change the display function. So that's kind of nice. Let's move on to another sort of example where we're talking about style sheets here. And so here we've got a my commutator. It's got a display function here. And so, it's working as we'd expect. And so, we can change that to Q and so on, and it'll feed that argument through. But it's a bit of a hassle to always display this. You have this display function. I'd actually like the display function to be associated with my commutator. In fact, just something a bit like that. But of course, right now, without the display function, it doesn't know how to display this. It still works. I can type in parameters here, and it'll still evaluate, but it doesn't know how to display that. So what I need to do is add this display function to the style name my commutator on the style sheet. So I can use this inject styles. It's just a small program, a small package I wrote, and so it'll inject it onto the style sheet of this notebook. Which style? My commutator, and it'll be template box options. It's going to write in template box options. And so, sorry, just a sec. Template box options. And we are going to put what option on the style sheet? Well, we're going to put the display function on the style sheet. And now when I hit Shift Return, this particular template box right here, it'll be able to actually pick up the display function option through the style sheet chaining inheritance mechanism, and it will know how to display that. So when I hit Shift Return, right here, this now displays correctly. And so, of course, I could change this if I wanted to, change this to some, some positive commutator or something else like that by just changing the display function. As you see, it's changed there, and I'll just change it back here, and it's back again. And of course, we could actually go here and edit the style sheet and actually see that indeed my commutator actually has those particular styles. Okay, so So let's actually then talk about extending this a little bit. This my commutator, when we're actually evaluating this my commutator here, it evaluates as my commutator because of the interpretation function. So let's actually just change this interpretation function here, and it's going to be a box function as this one is, but it's which box function will it be? Well, instead of my commutator of a comma b, let's actually make it a quantum commutator. Quantum commutator. And so we can just grab the boxes for a quantum commutator here, paste those in, and of course we want them to be parameterized, so we'll just paste in this parameterized string functions. And now when we change that, we evaluate this, we can actually turn around and get a quantum commutator. And so of course now when we copy this out, we go to an external program and we paste it in, we'll actually see I'll get to that. Yeah, Nikolai, I'll talk about that in a second towards the end. I'll take questions at the end. So that now the interpretation function, the copy function, it defaults to automatic, which depends on the interpretation function. And so we can add another box function, which is the copy function here, and we can actually change that right here. And so we can have, this is going to external things, so we can have a Mathematica quantum commutator, for instance. And so now we can actually go copy that to an external program here and paste it in, and we get a Mathematica quantum commutator. And so the display function tells it how to display it. The interpretation function tells Mathematica how to interpret it, and the copy function tells Mathematica how to actually write this out to sort of external programs. And so, and we put this all in the style sheet. So of course we don't need to actually, put it on any one particular thing. And of course we could turn around and make a rule for this and make it a quantum commutator, for instance, here, a make boxes rule. It's pretty simple. And so now as we enter that, we get this whole thing and it's working. And so we've extended this with just a make boxes rule, and we have a full quantum commutator. Okay. So then let's actually move on to say formally what a template box is. And a template box is basically a parameterized list of a parameterized set of boxes, which are the parameters, and a tag. And the tag, if it's a string tag, will actually go to the style sheet and look up the actual options for that template box and use them to actually style the template box. And in this case, it'll have the display function. And the display function will be applied to the actual boxes, which will show it how to display. That will, and of course, they'll feed back in as you edit the sort of various arguments. Okay, template boxes can be nested at any particular level. And here we see this particular, we're going to change this to an M, for instance, and we see this is, binomial M comma B. And one of the things we might want to do is, in traditional form here, we can actually see it's M comma B as a binomial. So we might want to actually change the display of that to something a little bit more like C, N things taken K at a time or whatever. There's a polarity there, but we'll just grab those boxes here and let's go off and actually change the binomials, how they're displayed. And so what we can actually do to answer Nikolai's question here, we can actually go off to the core style sheets and actually find binomial. And there's a lot of different template sort of styles because it's used like everywhere. So we'll actually go take a look at the binomial style in particular, and we can actually see that indeed, this is what we thought it was going to be. It was going to be the display function was a row boxy sort of thing with a grid box in there. So let's actually grab that binomial, go back here, paste it onto ours, and actually change it and change this display function to be more like this subscript box, and it remains to just change these to numbered slots 1 and 2. And when I do this, I put this in, you'll see when I hit Shift E, Command Shift E, you'll see these change throughout the notebook uniformly to this new notation for binomials, of course. And now we could just get rid of it, change it all back, and now all of our binomials will change back. And so we can uniformly change the way things are displayed throughout a particular notebook or set of notebooks by changing the style sheet. Okay, so this then allows us to move on to association template boxes. And so let's actually make a template box for this Lie derivative bracket. And so we know the drill by now. It's raw boxes of a template box. And so it's going to give a list of parameters here. We're going to give it a name. Let's call it Lie derivative. And let's give it a display function, for instance. And looks like that. And so what is the display function going to be? Well, we're going to go grab these particular boxes, get those, put those in. That's our display function. And now we'd actually go through and change this to slot 1, slot 2, and so on. But actually, it makes sort of sense that we'd like to actually have this like X and Y. This sort of makes sense for Lee derivatives to actually label these things. And so if we want to use string slots, we actually have to use the following. So just to give you a refresher, if we have pure functions in Mathematica, like so, this will take a couple arguments, a comma b, and it applies those that strings the slots, those arguments to the slots, and we get that kind of result. What happens if we want to actually make those named slots, string slots? Well, that won't work right now because we don't actually have any names. So we actually have to give it some keys. And so the keys, of course, would be an association. And so we can turn around with the association keys here, and we get like so. And so we have this string, this pure function with string slots applies to associations. And so instead of actually putting in a list of parameters here, we could actually just turn around and put in an association here. And we want, x goes to x. X goes to x, y goes to y, for instance, here, and t goes to, I don't know, w. And so now this the string slot function will actually be applied over this association, and now it behaves just like a normal template box. We can change the particular parameters, change that to q, w and r, for instance, and we actually see all those parameters are being fed back into the parameter list of the association. Okay. So, of course, since this is what we've done before, we'd actually like to put the display function onto the style sheet, and we do that as so. And so then we actually have, just like before, we have this working with just a very simple template box with these named parameters, and which sort of makes sense. And we'll see why that's actually sort of important in just a second. So leading up to that, I'd like to actually then talk about the template boxes with no actual parameters. And so since it knows what the display function is, it can actually go here, and we can actually just sort of fill them out like so, and these get filled out in the same way with here. And why do we want this? Of course, j, k, p, for instance, and it works like we would normally expect. Well, it turns out that we want to actually be able to enter notations. It's being covered up by my picture there. We want to be able to actually enter in aliases, and so we want sort of an alias, of course, for the Lee derivative here. Why this is important, and so we can come in now and we can actually add that. And so now we add a Lee derivative here and another Lee derivative, and so we can add some parameters here, and it works as you'd expect. Okay, so this allows us, and of course, we've just added, of course, this template box without any parameters. So as we change this display function to have more or less parameters or whatever, it still will actually work depending on the display function. So it's quite a nice feature. Okay. Slot sequences, I wanted to actually mention this. This is probably familiar, hopefully, for pure functions. We can actually use a slot sequence, and on a sequence of functions, A, B, C, D, E, or something. And what that does is it takes the functions from that point onwards as parameters. And so you can actually sort of see it working here. We've got the same sort of thing with template slot sequences as well. And so this will take a riffle element if we want, put this in, and it riffles between the elements. We could go from the second element through to the fourth element, and so on to actually do it. And we can go in and actually change one of these elements here, y, and we actually see it feeds back into the template box arguments. Okay, and the same sort of thing. This is useful for, in some situations, is true for association template boxes. This is going from the bth element. We could go from the bth element through to, say, instance, the dth element here. And so b, that would be v, w, and x here, and it works as you'd expect. Okay, so with that, I can now move on and talk about some of the things that have actually changed. Apart from some of the other extensions from behind the scenes things, this is something you'll actually notice. And this came about because I did our ligature support. I implemented this, and so it broke one of the sort of fundamental tenets that we had in the front end, that selections wouldn't actually change sort of formatting, and these things sort of jiggled around. This was a desired effect to really sort of show where we were in the actual structure as we move through it. So given that we did that, I went back and I actually sort of enhanced the underlying template box arguments here. And so, of course, this is specified for just this Lee derivative here in this particular template box, but it can be added to the style sheet just like you've sort of seen these other ones. And so we'll get a couple of these things. And so now as I cursor in, all of these editing highlight options will actually kick in. And so now we can actually sort of see it's very clear which of the actual arguments we're editing. And we haven't turned this on for any of our own sort of functions, but it can sometimes get a bit get a bit difficult to actually tell what are the actual arguments we're editing versus what's the sort of scope of the whole template box. And so this is one sort of way to actually sort of do that through these particular arguments. And of course, we could change this to be something, I don't know, kind of crazy, 50 or something else like that. And so, we move something in, it goes kind of crazy. Okay, right. So that's editing highlights. To move on to now this uniformity now of this dynamic template boxes, let's take a look at a dynamic here of X and a slider of the dynamic of X here. And so this is, you've probably all seen this kind of stuff before. And in fact, if I get a second slider here, you see all of these values are all moving together. What I'd like to do is have a sort of template box where as I move the slider, that value of the slider is actually feeding into the template box. And in fact, you might even be able to guess the syntax for this. It's actually, we're adept at this. We're going to go in here. We're going to call this, could be anything. We'll call it a dynamic slider. And we put in a display function as before. Display function goes to something else like this. And so that's our form. What boxes are we going to put in here? We're going to grab these boxes. It's the slider box, put this in, and it's going to look like this. So what do we put here as an argument? Well, we could put sort of a #1, but that's kind of weird. We could put a #x here, which means, of course, we'd be using an association template box and put in here, X goes to some parameter, 0.3, for instance. And now when we actually move this slider, we see the actual value feeding back in. And so as I move the slider, we see that value actually feed back in. And of course, we can evaluate it and it comes out as dynamic slider. We can change this to, foo dynamic slider, and it would give a foo dynamic slider and so on. And of course, in the same way as we did before, we could actually turn around and inject the styles onto the style sheet. And so we don't even need to put the display function in. And so it's just this nice sort of template box of a dynamic slider. And of course, as you notice, none of these A's are connected from this other one to here. They're isolated, just like a dynamic module box would do. Okay, and so this allows for we can give a few more complicated examples here. Here we have a slider box with some a dynamic there, and it evaluates, and of course it's feeding through to the parameter. Here we have two connected sliders, as you'd expect. Here this evaluates, and of course we could put it as a checkbox. Here we've got A goes to true, A goes to false here, and so on, and it evaluates as we'd expect. And so you might think, well, this is just a sort of normal extension. There's nothing too special going on. Why is this important that we've now tied together template boxes and dynamics, and we've got dynamic template boxes? Well, so here's an example. Here's this RGB color, and so it has the right nice full form. It works as we want, and we can go in and we can change the particular values, and it looks kind of nice. It's got this nice, and the actual value changes. But if we go and actually take a look at the underlying boxes for this, we actually see it's interpretation box, a button box, a toolbox, a graphics boxes, a button functions. Wow, right. So it's kind of big. Wouldn't it be nice if we had something a bit more like that? Just a template box of the color RGB and RGB color swatch template, and all of those controls and everything, and feeding back into the template parameters and everything was all done on a display function on the style sheet. And in fact, we do have this, and so we can actually do these kinds of things. And it turns out, unfortunately, though, we haven't turned it on. We're still the kernel's still spitting back boxes like this, and it's doing this for compatibility reasons. And so in some future version, of course, if we had changed something as fundamental as color, right now and future versions, if you save it right now, you go to an earlier notebook, that they wouldn't be able to actually open it, and we don't want to do that. So maybe around 13.1, 13.2, or something later, we'll actually pull the switch and actually go to a nice form, nice very compact form of this everywhere. And likewise, we've got this with a linguistic assistant. And this actually highlights why it's really nice to have template box associations. Is like here, open is the fifth element. And so if you went through something like this and you're looking here and you saw #5 there, is that open? Is it something else or whatever? But with a string slot, it's actually really nice. And so you can actually sort of see that. And of course, this works just like would expect, and sign Y will go after Wolfram Alpha and do its thing. But of course, control equals will actually have this particular box function as you'd sort of expect. I can sort of see some stuff going on. Oh, and John actually said they're actually turned on for 13. Yeah, so these are actually turned on. I thought we were waiting till 13.1, but there you go. So they're actually turned on. Okay, so I'll just talk very briefly about the internals here. Actually, the scoping actually works by just exactly like a dynamic module box. And so we can actually get a dynamic module box. Dynamic module box, give it some value, x equals 0.3, and turn around and have a slider box of, and take this whole structure there and turn around and change that to an x. And just like we have in our expression here is going on, we have this to actually work here. And we want to row boxes of that, and it's working as you'd sort of expect, and it turns around as we change the sort of slider, the actual value of the actual dynamic module box changes. And so what happens is the template box, when it actually detects a sort of dynamic-y sort of thing, you know, a slider box or, you know, pop-up menu or, you know, input field or control box or some of those particular things, it'll actually wrap its internal argument with the dynamic module box, and the dynamic module box will actually take care of some of the management of this, and then the template box will actually sort of read some of those values out. And so, you know, we could actually go in and, you know, we could even put in some, you know, I'll just do this on the fly. Y goes to, you know, big or something else like that. Big here, and we'll put in at the beginning of the row box here, we'll put in hash Y, for instance. And so to just show you this is actually sort of working. And so big, and we can change that to, you know, small, for instance, and so on. And the whole thing actually sort of, you know, works as it should. Okay. And so to see those internals, you can actually sort of see here, we've got this dynamic module box. This is some C++ output. You can actually sort of see it actually working right there. Okay, so very quickly, I wanted to actually talk about the notation package. There was, because of some snafu in the actual beta, it's not actually, it wasn't working, and there was a problem in 12.3.1 that actually sort of went out that I didn't actually get to, but it is now fixed, and it will be going out absolutely for version 13. But here's a typical example for, you know, this is some ring plus and ring times, and so we can actually go here and actually form a notation for this, and we'll go, you know, A plus, and we'll have this as an operator, you know, ring, you know, B and ring, and I'm almost done, by the way. So ring plus in here, and so that's our definition for ring plus, and we have something for like ring times here, and now this will actually work. It has the right particular full form, full form. And of course, we could actually go in here, you know, change that to input form here and change this A plus B, you know, C over 2, for instance, and this will have, sorry, back to standard form, get rid of that full form wrapper. It'll have the right grouping and precedence rules because of parenthesize. And so one of the things I was going to actually mention here, of course, you can use the notation package. We did some of these rules by hand for make expression and make boxes. And in fact, you can use the notation package with this particular option, and it'll come through and it'll spit these kinds of rules out. And you can actually see it's using parenthesize instead of make boxes, and which will do this proper parenthesization. And it's a bit of a wrinkle, but it's something sort of fundamental. So it's a very useful package, and it's new and updated in 13 to work with that and some association template boxes and some other functionality as well. Okay, so one of the things I haven't talked about syntax forms. I haven't talked about base style and default base style, context-dependent parsing. I haven't really talked about tag boxes and old style parsing or evaluation and make boxes. See some of my previous talks for some of this other stuff. I will be around. I will be answering some of the questions now. Yeah, it's a very fundamental part of the front end. It's very useful, and so right now it's still quite accessible for you to actually create your own template box notations by just entering a 2D typesetting structure. You create this a template box with that box structure as the display function, and you just put in string numbered slots or string slots, and put that on the resulting on the style sheet. Create a make boxes rule, and for bonus points, put an input alias, and boom, you can actually join the extension of Mathematica just like we do internally to add new functionality to the Mathematica in the front end. I'd like to point out some related talks here. As John's talk has actually been, Lou's talk's been, James' talk has been, I think Yusu's talk is coming up, and Bignia and Jonta's talk is coming up as well. And so they'll probably go through some of the stuff that I've talked about in a bit more of a sedate fashion, with probably a little bit less crazy and a little bit slower. So I'm ready to actually take questions now. Let me actually look at the questions we've got. If you have a name of a, so Nikolai asks, if you have a name of a built-in template box, how can I extract its display function and interpretation function? And so, and somebody's actually replied to that. John has actually replied. You can query the value of any style by doing current value style definition of style names, a template box uses this, blah, blah, blah. So you can just pass in and you can sort of see this in the chat. So, and of course, actually, people might not be able to, if this talk goes live. So John has actually said, you can query the value of any style by doing current value of style definitions of style name. A template box uses the template's name as the default style name. So you can just pass in the template name and see if the style sheet sets a value for template box options display function. And John is, of course, totally correct there. Pierre says it's magic. I hope so. I hope it's good magic rather than bad magic. And Kessler has actually asked, I write my packages in notebooks with initialization cells, and notebook option auto-generate packages goes to automatic. How to let Mathematica know of a new box definition such that the correct code is written for package.nb to package.m. So that is, so if your typesetting uses tag box or template box, it'll write the box form. If you have, for example, a novel subscript box, I strongly recommend wrapping it in a tag box or a template box. And so there is a topic, of course, and it goes beyond just this quick zip through of a taste of what's going on. Let's talk a little bit later on, but there's a way to actually sort of package up. You've seen sort of inject styles. I'd take out the heart of that to get sort of what you want onto the style sheet, and then you write your own make boxes and make expression rules to actually put that in. And so with just that, you can write a package and that you can evaluate that, and so you just go and get the heart of that. I think I put it on here, inject styles here, and so you could actually be able to take that out, go here and rip out some of the actual bits, just include some of the bits into your own notebook, and then with the make boxes and make expressions, you'd be able to actually sort of inject the styles that you want in somebody else's notebook when they load up your package. Okay. This talk should be expanded into Wolfram U course. Very useful. Yes, maybe. And I think that's it for the actual questions. We will be around to answer any questions that you have, and I'll be around for the duration of the conference. Email me, jasonh@wolfram.com. I guess that's at the beginning right there, jasonh@wolfram.com, and I'll endeavor to answer your questions. Thank you very much then.